Okay guys, we're back, still talking about Unit 7, Lesson 2, and all I really want to do is find the asymptotes of these graphs, or these equations here, right? And then go through one graph together. After that, I'm going to cut this video and I'll make a third going through these examples. We did these in class. Those of you that were not here, you missed that, but I'll just discuss these and not rewrite them. Okay, these I'm gonna do from scratch. So, okay, this one. Well, to find the vertical asymptote, I'm gonna look at the denominator. If I set that equal to 0, right? If I say 8x minus 2 is equal to 0, that means 8x is 2. And if I solve for x, I get a fourth. Okay, so this is our vertical asymptote. Okay, I can plug that in here. 1/4, I don't get 0. So this is textbook, right? 1/4 makes the denominator equal to 0, but not the numerator. To find the horizontal asymptote, I just look at the top degrees of the top and the bottom. I've got degree 1, degree 1. They're the same. So I'm going to just take the ratio of the coefficients. Okay, so for the horizontal asymptote, we have the same degree, same deg, top and bottom. All right, top and bot. And that degree is 1. So the horizontal asymptote will just be the ratio, gotta write HA, will be the ratio of those coefficients. So I take y equals, the coefficient of the top is 4, the coefficient of the bottom is 8, so y equals a half, right, is the horizontal asymptote. Okay? Second one, x squared plus 7 can never equal 0, so this one has no vertical asymptote. Okay? There is no vertical asymptote for this graph. For the horizontal asymptote, well, I've got degree 0 in the top, I've got degree 2 in the bottom is bigger, so the horizontal asymptote will be y equals 0. Easy, y equals 0. And I'm going to say the bottom degree is bigger than the top degree. Okay? If I look at letter C, well, here are my highest degree terms. In this case, the top is bigger. So for my horizontal asymptote, there isn't one. None. Okay? This is because the top degree is greater than the bottom degree. Okay, I know there's a lot of cases, but again, what that really means, if the top is higher degree than the bottom and x is getting really big, well, this fraction just isn't bounded, right? The numerator is getting bigger than the denominator, so there's no horizontal asymptote, right? There's no limit. For the vertical, I want to see, can this equal 0? So let me just write that. This is the vertical asymptote stuff. So I want to factor, or try and solve, is 6x squared minus x minus 2, is that ever equal to 0? So is this going to factor? Let's see. So we got a 3 and an x. Yeah, I think if I make, oops, sorry guys, that's not good. I have a 3x and a 2x, and I want a minus 1. So yeah, let's make this a minus 2 and a plus 1. So if I set that equal to 0, let me just double check. If I multiply that, that's 3x squared. That's negative 2. And I have, positive 3x minus 4x, which is negative x. So I'm going to have two verticals, I believe. We've got x equals 2/3. And here I've got x equals negative a half. Okay? So those are the two vertical asymptotes because they make the denominator equal to 0, but not the numerator. I hope I said vertical asymptotes. Yeah, those are the two vertical asymptotes. Okay, last one, right? Well, for the vertical, we'll set this equal to 0. So for the vertical asymptote, and I'm just going to kind of speed up this process, that means x could be plus or minus 4, right? Plus or minus 4. 16 minus 4 squared is 0. 16 minus negative 4 squared is also 0. Okay, and when I plug this in, if I plug in positive 4, all the terms are positive, so I never get 0. If I plug in negative 4 here, that's going to be negative 20. This is going to be 32 plus 1, so it won't be 0. Okay, so both of these values make only the denominator 0. And for the horizontal asymptotes, we look at the degree. We've got degree 2 in both. So the horizontal asymptote will just be at the ratio of those coefficients. Okay, so it's going to be at, in this case, negative 2. Why? Again, degree 2, leading coefficients 2, leading coefficients negative 1. 2 divided by negative 1 is negative 2. Okay. All right. How are we doing for time? We're doing okay. So this last one, right? This is the process. We've talked about this before, but step by step, what do we do to make a graph of these rational functions? Well, we get the asymptotes first. Usually we'll do the vertical asymptotes, right? Find those first. Then we'll find the horizontals, okay? Then basically we want to get some points, okay, and get the general shape of the graph. So I've started this one, right? We've got a factored form in the bottom. If x is negative 2 or positive 2, the bottom is 0, the top won't be. So those are our vertical asymptotes. X equals plus or minus 2. So here's one. Should make that maybe a little, it's clear. It's clear enough it's dashed, I think. So that's x is negative 2. And we've got another vertical asymptote at x equals positive 2. Okay? Next, horizontal asymptote. Well, in this case, I've got a degree 1 on the top, a degree 2 on the bottom. So the degree of the bottom is bigger. So my horizontal asymptote, I want to do this all in the same color, is going to be y equals 0. Okay, again, because the degree of the bottom is bigger than the top. So that's our horizontal asymptote, y equals 0. To find the y-intercept, right, we're specifically asked for these. Well, so we can put 0 in. That's 0 over negative 4, which is 0. So that's a point. Now look, guys, that's, right? That's actually on the horizontal asymptote. That's okay, because remember, this is a guiding end behavior type of thing. So occasionally you will have the horizontal asymptote gets touched. The x-intercept's actually the exact same thing, right? So I got the same point. And for domain and range, well, the domain, this is going to depend on the vertical asymptotes. I only have 2. X can't be negative 2. X can't be positive 2. So I'm going to say the domain is all real numbers, except x cannot equal 2 or negative 2. And for the range, well, let's make the graph, but it looks like it's going to be everything, right? Our only horizontal asymptote at 0 actually gets touched. So most likely this graph's going to cover all the y's, but we'll see. So I want to know, what's going on. Does the graph look like this or like this? Does it do this or this in the middle? Does it look like this or this on the end? So I'm going to pick a couple test points. So I'm going to test like, let's test negative 4 and maybe negative 1 and positive 1 and then positive 4. Okay, so I'm going to make a table of values somewhere. I think I'll make it over here on the top right of the problem. So we're going to pick, we said negative 4, negative 1, 1, and positive 4. I hope these numbers aren't too big. Okay, so -4. If we plug in, we get -16 over 4 squared. And -4 squared is 16 minus 4 is 12. So that's like -1.3. -1.3. So I'm going to put that like down here, right? It's basically 4 over 3. Okay, and from that, I know that my graph has to do this. It has to approach both these asymptotes. Okay, it's not going to cross this, because if it did, there would be another 0. The only 0 of this graph occurs when x is 0. Okay, -1. Well, if I plug in values for -1, if I plug in x equals -1, I get -4 over 1 squared minus 4, that's -3, so I get positive 1/3. Excuse me, positive 4/3. So at -1, I get positive 4/3. Okay, that tells me the graph's looking something like this, right? Again, it can't go like this, because that would create another 0. At +1, well, at +1, we're going to get 4. Shoot, I want blue. We get 4 over -3, which is -4/3, which is like somewhere here. Okay, so then, you know, you can kind of see what's happening. The graph is going to turn like that. Okay, in the last case, if x is +4, well, we get 16 over 12, which is +4 over 3. So when x is 4, we get 4 over 3, and we get this part of the graph looking like that. Okay, so you can just pick test points to guide the rest of the graph. All right, so our range is actually what we thought before. It's all real values, right? We have everything below 0, right, covered here. We have everything above 0 covered here. We have 0 right there. So the range is all real numbers. And that's enough for video 2. I'll see you on the 3rd one, where I go over just explaining these graphs. And let me just double check that that's what I want to do. Yeah, see you on the next one.